Hi, this is Erica, and I'm doing the valence bond theory diagram and the crystal field diagram for FeCO4CN2. But first I'm going to answer a few questions so that can help me draw both diagrams. First I want to find the formal charge, that way I know what iron molecule I'm dealing with, be it 2 plus or 3 plus. I know Cn has a charge of -1, there's 2 of them, so that's -2. The overall molecule does not have a charge, and I know that carbon monoxide does not have a charge, so that's 0, which means iron will have to be +2. The coordination number is 6 because iron is bonded to 6 ligands. That tells me the shape will be octahedral. Both carbon monoxide and cyanide are strong field ligands, so that's strong. And because I know they are strong, that tells me that the pairing energy is going to be less than the splitting energy because it's going to have such a large crystal field split. Because it has such a large crystal field splitting energy, that will make it a low spin. The magnetic properties is asking if it will be paramagnetic or diamagnetic. Because it is a strong field ligand, that tells me it's going to be diamagnetic. And the hybridization, I have the option of either sp3d2 or d2sp3. Because it is a strong field ligand, it will be d2sp3, which I will demonstrate. So now I'm going to do the valence bond theory diagram. I know that is a iron 2 plus. Those 2 electrons came off of the 4s because 4s is a lower energy level than 3d, so therefore we still have 6 electrons in the 3d orbital. First thing I'm going to do is I'm going to pair all of these electrons. So I'm just going to bring these 2 over here. So I need to add pairing energy, which means all 6 electrons, each of these little arrows is an electron in the 3D orbital. Next I'm going to hybridize. This is the, sorry I didn't mention before, this is the ground state. This is the excited state because energy is added, making the electrons excited enough to go into the other orbitals. And I'm going to, because I have 2 empty 3D orbitals, I'm going to hybridize 2 from the 3D, the 4s, and the 4p. So now I have only 3 in a 3D. And I have 6 from the D2sp3 hybridized orbital. I'm going to put all 6 pairs of electrons. So there's 6 sigma bonds. 4 from the carbon monoxide and 2 from the cyanide. And that will make this the bonded state. And lastly, this is the crystal field diagram. As I mentioned before, because it is they are all strong field ligands, it will make a large crystal field energy, which means it's a very large split here. That will make it a low spin, so all 6 electrons are going to go in the plus 2G level as opposed to spreading out into the EG. If it was a weaker ligand, it would be a smaller crystal field energy, crystal field splitting energy, and they would go into the EG, but in this case it is a low spin, so they all go in the 2+ level, and which matches our 3D diamagnetic orbital.